All right, so as promised, I'm just going to go over a little mini lesson for 2.3 and 2.4. That is the sine law. Now, the sine law was pretty straightforward. The ambiguous case is, thank you, the ambiguous case here is probably the biggest concern, and then the cosine law, okay? So let me just take a look real quickly at the sine law. The sine law happens or can be used when we have a non-right triangle where we do have a angle and opposite side that is known, okay? An angle and opposite side that is known, or an angle and opposite side that can be easily determined. For example, I have an angle but no side that's given. I have an angle but no side that's given. I have a side with no angle that's given. However, this would be able to be used for the sine law because we can easily find this angle. And then we have this pair. You see that? So if you have angle, side, angle, you could actually find this third angle. So what's 180 minus 88? That's going to be what, 92. Minus 61 is 35. So this is going to be 35. That sound about right? So now I have an angle and side pair. That's great. So what you can do is you can use this as our initial, 31, 8, 9, 31, 31. So you can use this as your initial angle side pair. So like over here, 1.8 over sine of 31 equals, and you can pick any side you want to begin to solve, equals b over sine of 88. You solve for b, and you'll get a value, and so on. You can do that again. Remember, for non-right triangles, you cannot use Pythagoras' theorem. That's only for right triangles. Question?
Flipped upside down.
Yes. Yeah, that's right. So are you talking about this here? Like a over sine a equals b over sine b, and then you could flip that around? Yeah, these are exactly equal. That's right. If you have 2 over 4 equals 4 over 8, that's the exact same as 4 over 2 equaling 8 over 4. See that? You just flip them both around. You still have an equality there. Okay, so I use the b over sine b equals this side over sine of this angle. I use that and I put the b up top because I wanted to isolate for b, so it's less work if I put it in the numerator. And then how do you know what to multiply by? Well, you have to get your unknown all by itself. So if the b is being divided by sine of 88, you have to multiply both sides by sine of 88, right? And so that will eliminate this sine of 88 right here. So as we move to the ambiguous case, this involves the sine law, but there is some ambiguity or some unknowns to this. So this was the example that we did in class, and again, I'll just summarize this real quick. If you're given an angle, okay, and here's the angle of 55 that we have measured here, and a side that's opposite, so when you have a large, the uppercase letter, that's an angle, lowercase of the same letter is the side that's opposite, always, in triangles. So this is the opposite side, 3 centimeters, I have that represented here. And side B, that's just an adjacent side to this angle, so you could write it on the bottom here, or you could write it on the side. In my teaching, I always encourage you to write this, or to show this in the same orientation where you have the angle here, the adjacent side up here, and then the opposite side over here. That's the way I teach it. There's a lot of, you can do that almost every time. Okay, write it like this so it's a bit easier to manage. But what you want to do in the ambiguous case is you first of all want to check for what is the minimum length required for this opposite side, because the minimum length will always drop down to this side and form a right triangle. So you go b times sine a. That is extremely important. That's always where you start when you're given a side angle situation, side angle. You always want to find out what is the minimum side length required. And that is, because this would be a right triangle that would be formed, then SOHCAHTOA would come into play, right? So let me just redraw this here. If this was 6 and 55, if I wanted to find out what this was, I would go sine of 55 equals the opposite side over hypotenuse, or 6. If I solve for the opposite side, I get 6 times sine of 55. And so that's what we've done here. We've taken b times sine a. That will give you this minimum length. So b sine a is always where you start. When you get b sine a, you compare that with the opposite side that's given. So let's get the calculator going here. If I do 6, on, clear, quit, 6 times sine of 55, what do I get? I get 4.91. What that means is that 4.91 would be the length required to have at least a right triangle here. That's the minimum length of side required, 4.19. If I notice that I'm given only 3 centimeters, that literally means that I do not have a long enough opposite side to drop down to touch this line to make a triangle. So this b sine a is really important. You compare with the opposite side. So in this case, no triangle would be formed, none, because the side that I'm given, the side length I'm given, is not long enough to complete this triangle. Got that? So what happens if, and here's that case right here, the side is too short. What happens if I do have a side? Now let's change this a little bit. Let's say that this was 5. Okay, 5. Well, I found out that b sine a was 4.19, so guess what? 5 is greater than 4.19. 9.1? Okay, 9.1. Thank you. 9.1. So if that's the case, then this side actually would look like this. It's a little bit longer than is required to form a 90-degree triangle there. And so what happens is I would take this and I would actually say, okay, if this is the length it has to be, I would have to swing this side over, and here's what it would look like. Now this is 5. You see that? So I could make a triangle that's not a 90-degree triangle, but it would look like this. The problem is that I can form more than one triangle with these given requirements or criteria. I can form more than one triangle. And what's the other one look like? The other one looks like this, where we have 55, we have 6, and then this 5 could actually swing the other way from 90, and this would still be 5. Yes, this length here of this side would be shorter, but we still have the criteria that we were given in the question. So that's where you get 2 triangles from. And again, this is a mini lesson. We've been through this before, so I'm not going to go over everything, but I think I do have some graphics here, or right here. Okay, so this is the one right here, you see, where A, in our case 5, would be a little bit greater than the 4.91 that would be the minimum height required. So you could form 2 triangles. All right, that's 2 triangles right here. Finally, this one here, if A, the opposite side, is larger than B, that means that this side is super long, and if you were to like literally pivot here and swing it over here, it would not touch inside the triangle. It would be too long. So if A is bigger than B, and you see that right away, you know that there's only one triangle. And just to accentuate that, let's say that this is B, and this is like a, whatever this is, 88 degrees. And then A is like way bigger than B, okay, way bigger. You can see that this is the only triangle that can be formed. Because if I were to try and swing this around, it would be like way over here. So those are the 3 options where the opposite side is shorter than the minimum requirement of b sine a, where a is larger than the minimum requirement of b sine a, which is this h, but yet smaller than b, and that's what this means. A is greater than h, but smaller than b, 2 solutions. And where a is greater than b, we are back to 1 solution. The other one that I guess I didn't mention in this mini lesson is, what if it's exactly the minimum height? Well, if a equals h, then we have 1 solution, and it is the right triangle that is formed. So that's the ambiguous case in a nutshell. Questions? So question about number 8 here. When you sketch this out, PQR, look at what you're given, Q. So I would always sketch, and I try to do this to scale as much as you can. Doesn't be exact, but 43 is going to be maybe something like, oh, that's not it. About here, 43. Nope. Maybe this one. The opposite side is Q. Look at the opposite side is Q15. And P would be the adjacent side to Q. So this is going to be 20. This is going to be 43. And Q is the opposite side. It's 15. So when I do this, like if I was doing this from scratch, whatever, I would like literally do this like, hey, I don't know if 15 is long enough, if it's longer than the minimum requirement. I don't know. 15, don't know. So how can I figure that out? Well, 20 times sine of 43 will give me my minimum. All right. So your question is, where do you put 15 and 20? The key is this. If this angle is Q, the little q is always opposite. It's always. Doesn't matter what the letters are. The uppercase is the angle. The lowercase of the same letter is always the opposite side. Well, okay, so the formula, when you talk about the formula, are you meaning B sine A?
Like H.
So in the original formula, B sine A comes from this. B is this one, A is this angle, and little a is the opposite side. H would be this minimum height, okay? For this one, I set this to Q because that's the angle we're given. So that means that this is little q, and this is P right here. So what you're finding when I say B sine A, I really mean here, if you're going to look at these letters, it's P sine Q. It's just this one times the sine of this adjacent angle here equals H. This is still H. So yeah, so if it's not ABC, you have to sketch it out. I would sketch it out. And then again, just look at the adjacent side multiplied by the angle. That gives you the altitude. So once you find out that the minimum is actually a little bit less than 15, then you can see that there are two triangles. Here's the one, 43, 20, and 15, right, this. And then here's the other one, 43, 20, and 15 over here. Okay, so one is just inside of 90 degrees and one is just outside of 90 degrees. And then you would solve those individually. Okay. Now, if you do the sine law here, so you've got 15, and you do 15 over sine 43 equals 20 over sine of this one. Please note that your sine law calculations will always give you an acute angle. Always, your calculator will give you an acute angle because nothing is positive or negative here. It will always give you an acute angle. So if you get an angle of like 32 or something, don't put 32 here, because in your sketch, you know that has to be greater than 90. So the 32 is actually this one, if that was the case. I'm just as an example. So I know that some of you have run into this in your assignments, perhaps, that using the sine law will always give you an acute angle. So you might have to use the supplementary angle for that acute angle to find the obtuse one. Okay, so just real quickly here, let me just try this. So just wait. 20 times sine of 43 is 13.63. Okay, so CH is less than 15, so I'm going to form two triangles. Sine law now, so let's take this one for example. I'm solving for an angle, so let's go sine of whatever this is going to be, big P, I guess, over 20 equals sine of 43 over 15. If I were to solve for P, I'd have to multiply both sides by 20, okay, to get rid of the 20 here. And then I'd have to take the second function of sine, so sine to the negative 1 of all this. All right, which looks like this. So I'm going to do second function sine of, and I'll use my brackets again here, sine of 43 times 20, bracket, divided by 15. Now, do I have the 1, 2, 3, 1, 2, 3? Yeah. So I have 3 left brackets, 3 right brackets. I've got the right number of brackets there. Okay, so 65. Notice, if I go ahead and put 65 degrees right here, I'm going to run into trouble because that's an obtuse angle. It obviously means this one is 65 degrees, you see, for this triangle. So in order to solve for this angle, you do 180 minus 65, which is what, 15. $115. 115, yeah. Yes. All right, so the third thing we want to cover in this little mini review lesson is the cosine law. So when we have a situation where we do not have an angle in an opposite side pair, so we have something like a side, 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 right? If we have three sides given, we do not have an angle in an opposite side pair, so you can't use sine law. And also if we have, what is it, angle, side, I think is the other one. So let's see if you have angle, side. No, that's not it. Hang on. All right, sorry, my bad. It's side, angle, side. So this is a side here. So you have side, angle, side, because notice you don't have any opposite pairs. So if you have either of these two situations, you want to look at the cosine law. The reason why it's cosine law is because we have the cosine involved in this law. Now, with the cosine law, this is the way I like to look at this, okay? The first thing you want to think about is this right here is very similar to Pythagoras, right? Very similar to Pythagoras. It's just got this little extra piece on here. So if you think about, this is the way I like to teach this. If you think about a 90-degree triangle, okay? 90 degree. The sides are related in a squared plus b squared equals c squared, okay? That's Pythagoras' theorem. Now what happens if this isn't 90? And watch carefully. The new sides here, let's make this angle a little bit smaller. Okay, so if it's not 90, then what happens is A actually gets bigger, B actually gets bigger, and so in order for them to equal c squared still, because c hasn't changed, you see, in order for this to equal c squared, we need to subtract a little piece. If A is bigger and B is bigger, that means A squared is bigger and B squared is bigger. It doesn't equal c squared anymore. So guess what? This little piece translates to 2 times the length of these two sides. Sorry, in this case would be 2AB, and then times the cos of this angle, which would be C here. All right, so that's the best way I think to think about it, not a 90. If A and B are getting bigger, then you got to subtract something away. It also does hold true, though, if A and B get smaller. If you have something like this, okay, and A and B get smaller, let's say, or A gets a little bit bigger, but B gets a lot smaller, well, then this is going to take care of it, okay, whatever, because sometimes this might be negative, right? Okay. The cast rule says that if this is an obtuse angle, this cos of that obtuse angle is going to be CAST. It's going to be negative, so you're going to actually add something. So it'll all take care of itself with this little end piece, and that's where the cosine law comes in. Now, if you need to solve for the angle, you can still do that as well. And, let's say we want to solve for A, okay? We've got B, C, and A. We've got a side, 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 and we want to solve for an A first. No problem. What do? Well, you're going to get everything over to one side except for A. So we're going to do this. See how I'm going to move B squared over here. I'm going to move C squared over here. They're both going to become negative. And then I'm going to divide by negative 2BC. Divide by negative 2BC. That's going to leave us with cos A. And now to get A all by itself, I am simply going to take the second function of cos of both sides. So there you go. This cancels off with that. The angle A is equal to this, the cos to the negative 1 of this right here. You plunk that in your calculator and you get A. All right, not that hard. It looks a little confusing there, but it's not that hard. So cos to the negative 1 of A squared minus B squared minus C squared all over negative 2BC. And again, this A squared here is the opposite side of the angle you're trying to find. So the one that's positive up here, this A, right, is the opposite side of this angle A right here. So you remember that. Okay, so that's your cosine law. There are lots of examples in my other videos and in the chapter review. So that's just a quick view of sine law and of ambiguous case and the cosine law. So I hope that helps. And I hope that helps you. Okay, MathWell out.